Scientific data has grown increasingly complex and rich over the last couple of decades, yet scientists continue to use methods of organization that no longer meet their expanding data needs. The main advantage of the technique described in this video is that it allows for a database that gives a rigorous data pipeline and storage while maintaining flexibility for data analysis.
To begin evaluation of the dataset of interest, download the example codes and databases shown in this table. Next, use this graphical representation of a multidimensional database to evaluate if the dataset of interest is indeed multidimensional. The data needs to meet two conditions to benefit from the database organization. First, the data needs to be able to be visualized in a multidimensional form, and second, it must gain greater scientific insight by being able to relate a specific experimental outcome to any of the dimensions. Relational databases store information in the form of tables, which are organized in rows and columns and can be used to link identifying information within the database. Multidimensionality is handled by relating different fields, such as a table's columns and individual tables, to each other. First, organize the data files so they have well-thought-out unique names. Good practice with file naming conventions and folder-subfolder structures allow for broad database scalability without compromising the readability of accessing files manually. Add dated files in a consistent format and name subfolders according to